Google. 90% of our engineers use the software you wrote, but you can't invert a binary tree on a whiteboard, so f off. Well, Max Howell got rejected because he didn't know how to invert binary trees. In this video, you will learn how to invert binary trees so you can get into Google during the interview. We know that a binary tree is a tree in which every node has at most 2 children, and to invert a binary tree is to swap the position of the left and right children of each node. The intuition behind this problem is to use recursion to break it down into similar subproblems with a smaller input. A key observation we can make is that inverting a binary tree is the same as inverting the left subtree and the right subtree, and then swapping their positions. For example, suppose we want to invert this binary tree rooted at 4. We first want to invert the left subtree rooted at 2 and invert the right subtree rooted at 7, then swap their positions. So now we have 2 subproblems with 2 smaller inputs. We then continue the process with the same approach, and we observe that to invert these subtrees, we only need to invert 2 leaf nodes, which can be done by directly swapping their leaves. After finishing inverting these subtrees, we'll go one level up and swap their position. So how do we come up with a formal way to solve such a problem? This is where recursion comes in. We can define a recursive function that takes in the root node of the tree. The base case is that if the root node is none, we return none. Otherwise, we invert the left and right children with 2 recursive calls and then swap their positions. The recursion continues until we reach the leaf nodes of the tree, at which point the function returns the leaf nodes themselves and the leaves are swapped. As a result, the function is able to invert the entire tree, starting from the root node and working its way down through the tree to the leaf nodes. This way, we can invert the entire tree in a single function call. This is the full solution to problem invert binary tree. I hope you found this video helpful. Please like, subscribe, and leave a comment. Thank you!